Yo students, Mr. Choi is going to play with these two balls. Both balls have the same mass, but one of them is called a lazy ball because it doesn't bounce. The other is called a bouncy ball because it bounces. He's going to swing the balls like a pendulum to see if they can knock down those Jenga blocks. For a fair comparison, both balls will be released from the same height. Only one of them will be successful in knocking down the blocks. Do you know which one? Pause the video, make up your mind, and come back for the answer. Alright, answer time. Looks like the bouncy ball hits harder than the lazy ball. It's a predictable outcome if you consider the momentum change of the balls. For both cases, the total momentum just before the collision is the same. So for ease of discussion, let's assume that the momentum of the ball just before collision is 1 mu. The momentum of the lazy ball after the collision is roughly 0. For the total momentum to be conserved, the Jenga block's momentum after the collision must be 1 mu. The momentum of the bouncy ball after the collision is negative 1 mu because it's in the other direction. So for the total momentum to be conserved, the Jenga block's momentum after the collision must be 2 mu. The fact is that the bouncy ball undergoes a larger change in momentum in the rightward direction. So the Jenga blocks must undergo the same larger change in momentum in the leftward direction. Because the net change in momentum in the system must be 0. But then, if the lazy ball comes to rest, doesn't it not lose more Ke than the bouncy ball? So shouldn't the lazy ball pass more Ke to the Jenga blocks? Good question, I leave it to you to think about the answer. I gotta go. Ta-ta!